Today we're going to be talking about parent functions and their transformations. So we're going to go over this PowerPoint right here. We're going to go from the beginning. All right. What I want you guys to do right now is I want you guys to take a look at this and ask yourself, if I wanted you to identify what this was representing, okay? If you had to have a multiple choice test like this, what best defines what's happening right here? Raymond. It is piecewise defined. Okay? So just remember, a linear function, everybody, you're going to have a line. An absolute value function is going to look what? It's going to look like this, or like this. A parabolic function is going to be a parabola. It's either going to open up or down. Okay? So I want you guys to understand what we're going to be translating, all right, or transforming is we're going to transform linear functions. We're going to transform absolute value functions. We're also going to transform parabolic or quadratic functions. Okay? So those are what we're going to be talking about. So yes, the answer is B. This is a piecewise function. Now, we have how many pieces working together? How many pieces? We have this part of the line. We have this. There are three things happening in this graph. So let's think about what those three things are. Okay? So I'm going to move over here. I'm going to write f of x equals. We have three things happening. All right? We're going to talk about certain sections. I'm going to make a blue section, a green section, and a red section. So when you see 3, 2, 1, and then go, see now it's recording. So what we're going to do is we're going to move back over here. There's your linear, there's your absolute value, there's your parabolic function. Okay? By the way, the parent function for all linear functions is y equals x. The parent function for all absolute value functions is y equals the absolute value of x. And the parent function for all parabolas is y equals x squared. Okay, so those are things you're going to have to know those. Okay. I'll slowly slide over. Linear, absolute value, parabolic. And just so you know, we call this quadratic. Okay? Now, moving over. I'm going to highlight three different things. This in blue, this in green, and this in red. Okay? So if we look, what's the slope of this blue line? 1 over 1. So the slope of the blue is 1. What's the y-intercept? If I went down 1 and over 1, my y-intercept would be at 0. So my y-intercept is 0. So actually, my line is just y equals what? Y equals x. We say f of x equals x. But then you would write if. If what's happening? Where does the domain start? Right here at a 1. All of my x values are greater than or equal to the number 1. That part of the graph is being graphed. And all values where x is greater than or equal to a 1. That's your first piece. Let's look at our next piece. This right here, what's the slope of this line that's horizontal? What's the slope? That's the y-intercept. What's the slope? 0. What's the y-intercept, Reagan? It's a -2. Okay? So if I said y equals mx plus b, right? Y equals mx plus b, which is slope-intercept form, you would say y equals 0x minus 2. But that just becomes what? Y equals -2. So my equation is f of x equals -2. But is everything being graphed? No. Where does it start? starts at -2, and that point is actually being what? It's actually being plotted right there, correct? But it's going all the way over to a what? Positive 1. So we would say if, right? If x was less than 1, but greater than or equal to -2. That's your restricted domain right there. That's the only points of the x's that are being plotted. Now let's go down to the slope of the red line. What's the slope of the red line? 1/1. What's the y-intercept going to be? Still be 0, right? So guess what? The blue line and the red line are the exact same line. So you just say x. What's being plotted?
Let's see. Anything other than -2.
X is what? Less than or equal to -2. Okay? Now you could actually, alright? You could actually combine these if you wanted to. You could say this or this. Okay? But I wanted to just break it down into its pieces for you. So you could say this is happening, alright, or this is happening. So those are your 3 pieces. But yes, it is a piecewise defined function. Now some of these are going to be really easy, so we'll be fast. Ready? Identify that. Absolute value. Very good. All right. Very good. Absolute value. Okay, here we go. Whoa, this is tricky. What kind of function is this? Piecewise, because it has multiple pieces. Okay. Now this one's kind of confusing, all right, because you're like, wait a second, which one do I use? Well, this function tells you what? The amount of money earned for working different number of hours. How much will an employee earn for working how many hours? 12. So let's think about it. 12 represents in the function the value for x. So does x fit here, here, or here? The first one, the second one, or the third one? Which one are you thinking? The second one? Let's check. If I plug in the number 12, is the number 12 between a 16 and an 8? Yes. So we use this function. How do we use it? Use it like this. You do 8.5 times 12, and you take away 1. So 8.5 times, what's 8 times 12? 8 times 12 is 96. What's half of 12? 6. You add them together, you get 102. Now if you're wondering what I did, here's what I did. In my head, this is what I did. I took 8 plus a half, which is what? Which is 8.5. And what did I multiply it to in my head? I multiplied it to a 12. Well, I know 12 times 8 is 96, and I know half of 12 is 6, and that equals 102. So without using a calculator, you can split things apart and use what property do we call this right here? We call it the distributive property. Okay? So you can break down numbers, it makes it easier to multiply. Here's what I did do in my head. I did not take 12 and multiply it to 8.5 like this in my head. Okay? Could you? Yeah, it takes a little bit longer. But I didn't do that. So what's our final answer?
Wait.
We had to take away a... It was 102, but then we have to take away a 1. All right. So here's all the different things you need to know. Here's your new vocabulary. Family of graphs. By the way, the family of graphs are your quadratic, your linear, your constant, all that stuff. Okay? You have this on your paper. If you look on your paper, you have all these vocabulary words. Okay? Oh, let me go back. Let's go back real quick. Now, for a constant function, okay? For a constant function, you're just going to write f of c is equal to a c. Like, what the heck is that? F of 2 is equal to 2. F of 5 will just equal a 5. 5. That's what a constant function is. A constant function is a horizontal line. A horizontal line, if I say y equals and I type in the number 2 and hit graph, what happens? It just goes. That's a constant function. So what would be an example of a constant function? This. This is where f of 2 equals the number 2. So a constant function, whatever c is, what does c represent? A number that's considered to be a constant. Very good. All right, so that's your constant function. I'll go back. Your identity function, everybody. Your identity function, if you want to know what that is going to be, your identity function is y is equal to x. When you think of the word identity, think of your ID. When you look at your ID, who should you see? Yourself, right? Well, if I say no, unfortunately, that would not be a good idea. Now, if y is equal to x, that means whatever x is, y is. So that's why you have a table. It's really easy to build. If I say x is 0, what's y? If I say 1, 2, and 2 and 2, and so on and so forth. Here's what your identity function is going to look like, everybody. You're going to say y equals x, and I'm going to hit zoom, and I'm going to square it up so you guys can see that it goes up 1 over 1, up 1 over 1, up 1 over 1. This is your parent function for all lines. That's something you need to know. Okay? Your quadratic function is going to be y equals x squared. This is the graph that you're going to see for all your parent functions for quadratics. Y equals x squared. That's what it's going to look like. Your parent function for absolute value, math, right arrow, enter. Here's your parent function for absolute value. Okay? What does the equation look like? Y equals the absolute value of x. What does the graph look like? This.
What is the parabolic one?
Parabolic one is your y equals x squared. It's your quadratic. Because, listen, your quadratic, what do we call this? We call this a parabola. Okay, that's why they refer to it as a parabolic function. Okay, or a quadratic. Okay. All right, that's it. There's your constant. So right now, if we were to look at all of ours, we have identity, we have quadratic. All right. We're going to be talking about different types of translations, reflections, and dilations. That's what we're going to do next. So right now, here are your 4 parent functions that you need to know. Okay? I'm going to go ahead and pause it right now so you have a chance to write them down. So if you need to go back and look at this, you can pause it. And you don't have to listen to me. You can copy everything down. So we're going to go ahead and move on now. All right. Identify that.
It's the absolute value.
There we go.
Of x minus 3.
Oh, now, actually, listen. If we wanted to say what the actual graph was, you would say this is f of x equals the absolute value of x plus 3. Now you're like, wait a second. Now you're wrong, Mr. DeMood. Where is it at? It's at a negative 3. But what number plus 3 would get me back to 0, 0? What number is negative 3? So I need you guys to understand this. When you guys are dealing with translations, okay, if it says f of x equals, and you do f of, and you say x plus a letter of a number, like the h is what? H is greater than 0. That's going to shift it that many units left. Okay? All right, so right now, everybody, what I'd like you to do is we're going to talk about translations, okay? We're going to talk about translations. We're going to actually use this as our guide. So in your journal, we're going to talk about translations. These are some examples, okay? If I have f of x equals my original function, whatever it is, in this example, here's what it's going to be. It's going to be the absolute value of x. That's what we're going to use in our graphing calculator. So our original function is just going to be the absolute value of x. It's our parent function. If I said f of x plus 3, that's going to mean it's the absolute value of x plus 3. What happened? It went 3 units which direction? It went 3 units to the left. Why? Because a negative 3 plus 3 gets me back to 0. So check it out. Go to your graphing calculator. Hit y equals. I want the blue function just to be the absolute value of x. So type that in exactly as it appears. This is your parent function. Okay? Then hit y equals, go down to y2. I'm going to hit alpha window enter, make it faster. I'm going to type it in x plus a 3. Now hit graph, look what happens. It shifts it over what? 3 units to the left.
You said x minus 3?
Nope. X plus 3, right here. 3 units to the left. Now look what happens if you change it to x minus 3. Look what happens. It does what? It goes 3 units to the right. So, if I have f of x minus 3, that becomes x minus 3, and that goes what? That goes 3 units to the right. Okay. So what do you think f of x plus 3 would be? That would be the absolute value of x, and then what am I going to do to it? I'm going to add 3. So what do you think is going to happen to this graph?
Is it going to go up 3?
Yes, it's going to go 3 units up. If I said f of x minus 3, that would be the absolute value of x minus 3, and that would be 3 units down. So either it's going to go left, right, up, or down. Okay? So right now, I'm going to keep moving forward. Yes, this is absolute value. What kind of function is this? It's quadratic. It's a parabola. It's quadratic. Okay? So by the way, how many units did it go to the right? It went 2. So by the way, the parent function, everybody, is y equals x squared. This would actually be parentheses x minus 2 squared. Okay? That's what this one will be. All right, so yes, this is a parabola, so it's quadratic. Okay. All right, what type of function is this? Constant, you're correct. Good job. That was good.
Parent. Wait,
Identity is correct. Y equals x. It's the identity function. Very good. Ooh, what's happening with this graph? It says x plus 1 squared. What's happening? It's moving.
Parabola.
It is a parabola, but which direction is it moving? It's moving negative 1 units. Yes. Okay, that's what's happening with this graph. It's going to the left. Okay. What's happening with this one?
Oh, it's going to the...
Yes, it is going to the right. Now, how do we know this? Because what number would you have to plug in there to make this equal to a 0? A positive 4. All right, so it has to be going 4 units. Which direction? To the right. There you go. It goes from here to there. If you did it in your graphing calculator, you would clearly see. All right, you will have access to a graphing calculator, but if you don't, you still need to know the rules. Uh-oh, something new. Right now, I want you to use a graphing calculator. I want you guys to hit y equals negative absolute value of x. Take a look at what happens. So right here, I'm going to go ahead down to y2. I'm going to clear this out. I'm going to say negative alpha window in x. And then hit graph to see what happens.
It didn't like I did.
What in the world is going on right now? It looks like it did something. It went something across. It's a perfect...
Reflected.
Very good. It's a perfect reflection. Excellent. So right now, I need you guys to understand this. If you see y equals a negative, whatever that function is, ours happen to be what? The absolute value of x, right? Okay? So if f of x, which is the original, becomes negative f of x, what happens? It reflects, no, across the x-axis. Nope. If you have, listen, I'm going to change colors here. If you have f of negative x, if you make your y values negative, it reflects across the x-axis. If you make your x values negative,
How does that work?
I'll explain.
Like, imagine if it's like on the y-axis. Like, wouldn't it just be the same thing? If it was flipped on the y?
Well, for these, yes. For those simple ones, yes.
Yeah.
Okay? So what would be a more, so what's going to happen with this graph? It reflects across what? It reflects across the x-axis. That's the answer to this one. It reflects across the x-axis. Okay, so what happens when it reflects across the y-axis? Okay, let me explain. So let's go over here. Okay, what I want you to do right now is I want you guys right here to do x plus 3 right here. Okay, I want you to hit graph. Take a look at the blue graph. Do you see that? Okay, now this is going to be kind of tricky. Down here, we're going to delete this, okay? I'm going to go right here, I'm going to open up a parentheses. I'm going to make all of my x's negative, okay? But then I'm still going to add a 3. So what's the only thing that's different? The only thing that's different is all of my x's are now negative, but everything else is the same, right? Now let's take a look at it. Do you see how this graph is now, what's the perfect reflection now? It's going across what? Now everything is going across the y-axis. You see how these are perfect reflections across the y-axis? Okay?
Wouldn't that be a translation?
No. It's not being translated. It's being reflected across the y-axis.
Translation is right.
Slid, yeah. Translation is either slide left or right or up or down. Now it does look like it's being slid, but it's really not. Okay? Here's why. Because I changed all of my x's to be negative. Okay? So right now, one thing we still need to cover tomorrow is what's called dilation. We'll cover dilation at the beginning of class tomorrow. Okay?